Hey guys, welcome to Safi Mixed. In this video, I will let you know how to verify the solutions of differential equations in Mathematica. For example, this is a simple exercise and we have given three different differential equations along with solutions, and it is asked to verify whether these solutions verifies the differential equation or not. So this is very easy, you can do that manually, but the purpose of this video is to let you know how to use Mathematica in this regard. So I minimize the windows of the question and put it here side by side. You see here the solution xt c1 sine hyperbolic t plus c2 exponent minus t. I have already written that over there, and I want to verify that this is exactly the solution to this differential equation. So what I do in Mathematica, I can do that very easily. I just write the differential equation by putting it inside the argument of simplify, and the single quote in Mathematica represent first differential, and then the double quotes represent second differential, and I put this inside the argument of this as t, which verifies that this is a second order differential equation with variable t. And then I put the double equal signs, and again to the right I put x of t, the same way as given in the question. You can see this is the differential equation, so I'm writing that in the same way, and then I add another bracket to close the argument of the function simplify. If I run this program by first pressing Ctrl A to select the two statements and then run this, the Mathematica gives me true. True means that yes, xt is the solution to this differential equation. You can do it through another way, that you can do by putting simplify, and then you put x, and then inside the argument you put again x double dot of t, and I close the argument, and I find this out, and if you see, it is the same result as given over here. The only thing is that the second term on the right in this equation is written as first term c2 exponent minus t and c1 sine hyperbolic t. Now let me write the second solution of the second equation. It is this one solution. If you see over here, xt equals 1 by 4 a squared t squared minus at2. So this is a solution as given in the question, and we want to verify that this is the solution to dx by dt whole square equals xt. So I do the same thing again. I just copy this thing and I put that over here, and this time this is not second order, it is first order differential equation. However, that one is squared, so the first differential is squared, and I'm doing it like that. Okay, one thing more, since xt has already been stored in the memory of the kernel of Mathematica with this relation, and now I want Mathematica to read this one as the x function, so that I can do by adding clear all function, and then inside the argument I put double quotes, then I write global, and then I hyphen, then static, then global quotes, and then I close this. And if I run this part, you see the x as a function of t is now blue, means it is no more in the memory of Mathematica. So I now run this to add this to the memory of Mathematica, and I run this, and you see again it says the solution, this is exactly the solution to this differential equation. And if I go the other way, I copy this, and I put this over here, and I set this as a single differential by removing one quote, and I squared this then, and I run it. Oh, I see, you see it is in this form, which is not exactly matching with this form of the function. So what I do, instead of using simplify, I want to use the function expand. And now if I run it, yes, now I have 1 by 4 a square, 1 by 4 t square, which is this part, and minus at divided by 2, which is this part. So you can use Mathematica to verify the solutions or to find the solutions of differential equations. Thanks for watching.